So this project was intended to be a simple inventory system where you can pick up items when you're close enough to them and hit the interact button, and when you walk close to a container, you could hit either the interact button or open your character's inventory with the tab key. And this is done through the inventory component. So this is something that is attached or added onto an existing thing. You just add component, and you add an inventory component to what exists. So you can name it, backpack, how many slots will it have, starting inventory, and then where the window will appear on the screen. So its physical location. Oh, that's not what I want. Select the viewport. So if I hit tab, it opens up the backpack. If I go over to this herb, hit E, adds it to the backpack. Then if I right click, it uses the herb, because the herb is a child of the item blueprint. So the item blueprint, if it interacts, it checks. There's an inventory component, and it'll add it to the inventory, and then it'll destroy the physical actor in the world. This is not one that's used in the parent class, but is used in the child class of the item herb. For the herb, when it's used, it just adds it to the counter that's in the corner. In this particular case, that's what it's set up to do. Under the class defaults is the item structure. And you can decide what entails an item herb. It is called a green herb. Is it stackable? This is the thumbnail that shows up in the inventory. Does it have a description? Is it consumable? How much can it store in one slot before it needs to move on to the next slot? And then what class is it considered? Now the item structure is an important part of how it creates itself. So we have an item structure and we have a slot structure. The item structure is specifically about the individual items, the child classes of the item blueprint. This is what determines what that actor is, and is used in the slot structure, which is an item structure and how many items. The slot structure, and the reason it's called that, is because it works with the UI. So each of these is a slot. And what's in the slot? Well, an item. How many of the item? That's the quantity. This is the quantity here. So currently have one herb. And for these containers, currently don't have anything in them. This one has 4 and 1. And it spills over 4 and 2. The inventory UI is what shows up on the screen. And it does that by creating a slot that is then organized into the inventory window, which is placed upon a canvas. So this guy is just a canvas. It's what everything sits on. This is the actual inventory setup. So I've got the tile up here. This is used to close, and then the inventory grid. It's only up there right now, but that's because it hadn't spawned in anything in this section. The graph does things like when it's constructed, how many slots should it make in the inventory? Well, you have to figure out how many spots in the inventory there are. So it gets that and it creates them. And it creates them using inventory slot. And then you add the child to the grid. So it's basically a grid of a whole bunch of squares, and the number of squares depends on how many slots you want. Then when you hit the close button, it'll toggle the inventory, and this helps to prevent the user from locking itself out of the inventory or out of the game. On key down is what happens when you click. Well, that's how it's set up. So it gets the input setting, and then it checks it if it's called inventory. So project settings, input, interact in an inventory. Inventory is tab or I, and this makes it so that in the future, if the input setting is changed, this still works because it doesn't care if you're hitting right click or I or tab or anything. It only cares if you're hitting the inventory input mapping. So it checks that, and then if it is the inventory input mapping, it will toggle the inventory. The toggle inventory is a function under the inventory component. A lot of the coding in this is under the inventory component. First, the event graph, it just prepares the inventory. So when the game starts, it makes sure it's set up. It sets it up by sizing the inventory array to whatever the designer has decided, how big should the inventory be. It then sets all of the initial items in the inventory. For example, this case, add an initial item here. We don't have to fill out any of this. We only have to put in which inventory and a quantity. So we walk over to this. It's got 3 herbs in it now. Boop. This gets what those initial items are, and it adds them, or adds blank, to what it is. Hence why it uses this class here. This is why all I had to change in the editor was the class, because it just gets the class, and then it gets the related item structure of that class, and just uses that. So everything in that chest worked exactly as an item herb should. And then I just had to set the quantity of however many herbs I wanted in it. That's how it prepares the inventory. If you want to toggle the inventory, first it has to figure out, is the inventory already up or is it not up? Because if it's not up, we need to create it. But if it's already up, that means you want to toggle it off. So if the inventory window does not exist, then we need to prepare it and create the window that it will show in. The UI has to be created. It's in the inventory window. It sets it, and it adds it to the player's HUD. And this sets the size and how it shows up on screen, where it shows up on screen, and sets the UI so the player can't move while they're in the UI. And then if the window already exists, then it needs to toggle off. So it removes it, and it resets the input mode to what it should be. So when we right-click an herb in an outside container, we want to add it to our player's inventory. It goes through the add to inventory function. So first we need to figure out, is it stackable? Because if it is stackable, then we see if in the inventory if a partial stack exists. For example, the herbs are currently set, they are stackable up to a max of 4, after which point they create a new stack. They take up a new slot. So what this does is, first, is it stackable? Herb is in fact stackable. It's stackable up to 4. Well, we have to figure out, well, are there any 1 are there any 0, 1, 2, or 3 stacks currently in the inventory? Because if there are, and yes, unfortunately this is spaghetti, but that's what this is for. It makes it look a lot nicer. So it takes the slot structure in the inventory and it tries to see matching classes already present inside the inventory. If there is a matching class, and if the quantity is less than the stack size, then it can stack. So a 3 will become a 4. So it keeps going until, so it checks all the slots until it has its answer. And then it gives us which stack index is that answer. This is what we're trying to go for. So if it is stackable, it comes up here. And if there is a spot where it can stack, it adds it to the stack. But if it can't stack, then it creates a new stack. Okay, so this section checks whether or not the initial quantity, for example, the player in their inventory has a stack of 2 herbs already in it. There's one stack of 2 herbs. And they're trying to take herbs from a chest. Say a stack of 2 herbs. So the 2 herbs that they have and the 2 herbs in the chest are added together. So that's 4. And then it's compared against the max stack size for herbs. So if the quantity is greater than the stack size, then it's false. 4 is not greater than 4. So if it's true, if it's not greater than its max stack size, then it adds the new quantity that's in the chest to the player's quantity. And so now the player has 4 herbs in their inventory and the chest has 0. If, however, there were 3 herbs in the chest instead of 2, that would mean that the player's quantity and the chest quantity exceed the stack size. So now we have 5, which is too much. So instead it creates a new stack. When a new stack is created, first it asks, is there space? The player's inventory has 4 slots in it currently. But if you have items in all 4 spaces, and you need to add more items than you have space for, you can't. And this checks, is there space? If there is space, then it makes a new slot and adds your items to it. If there is not space, then you can't add it. Nothing happens. So for example, create a new child blueprint, call it a cone. New class default, item structure, call this a cone. UE for logo. This is what we're going to use. It is not stackable. Just a cone. So the mesh, I'm going to change it to a, don't know why I typed cube. I'm just used to typing cubes, I suppose. A cone. So now it's a cone. Max stack size of 1. And it is a cone. It is not consumable. So basically I made it the opposite of my herb. And I can drag it in. And nom! It's now in my inventory. I can't right click it. It's now just in my inventory. A second cone. They're now in 2 spots. As for the containers, go in here, you just drag out container blueprint, container actor, sorry. You just pull out a container actor. You can set its mesh. Let's set it to a barrel. kind of on its side by default. Ah, okay. Okay, yeah, I was turning it. So let's turn it upside right. Let's call it a barrel. This is the name that appears at the top here. And now we will change the scale of the mesh transform a little bit so that it's more encompassing. Whoop. Now let's add a starting item to it. Let's add a cone. Let's add one cone. Another item, let's add herb. Let's add 3 herbs. This one, it's got 1 cone and 3 herbs. Whoop, whoop. 1 cone, and this spilled over.